Alright, welcome back. So let's look at our last lesson for this week, where we are going to be looking at the difference between predicted and experimental yield, but mostly our lesson is going to focus on percent yield, so just another way to calculate how well an experiment has gone. So just remember, like, stoichiometry is used to test experimental designs, technological skills, purity of chemicals, quantitative nature of particular reactions. It's used to test a whole bunch of things. And then, of course, we are going to be looking at our percent yield. It's just like percent difference, where it's just a number to express the success of a chemical reaction. So just remember, when we're talking about our predicted yield or our theoretical yield, this is the maximum quantity of product expected from a reaction and is completed using our stoichiometry. Now, our experimental yield, or our actual yield, this is what we obtain from our reaction or experiment. So it's what you physically have at the end of a reaction. And percent yield, it's a ratio or a difference between the actual yield and predicted yield expressed as a percent. So of course we need to do this because not all reactions are quantitative, meaning that they go to 100%. So there's many different factors that can affect how much product you can actually get from an end of a reaction. So one of them, slow reaction time or insufficient time to let all the reactants kind of react or collide with each other and produce the products. And of course, collection or transferring methods as well. So when we produce a precipitate or a solid, sometimes we can get low solubility product can dissolve a little bit, or mechanical losses like stuff sticking to glassware. When we try to pour it out, it just sticks to the side of a glassware and there's no way to get it out. Or even when we're trying to transfer it and it gets stuck to a filter paper, it gets stuck to our stirring rod, it could be anything. And of course, reactant purity is one as well. If we do not have reactant grade chemicals, that can cause a problem, but even reactant grade chemicals contain some impurities. So normally reactant grade, we classify them as 100% pure, but that's not the case at all. There's always impurities in there. And of course, reactions don't always go to completion, meaning that we don't get 100% of the products being formed. And another thing that can happen is competing reactions. And this is, for example, like combustion reactions, when normally we write it as carbon dioxide and water vapor being produced. But sometimes we get carbon monoxide being produced. Sometimes there's solid carbon being produced. So we get these competing reactions that can then hinder how much product we can actually get. So these are just some of the things that can happen during a reaction that will cause us not to get everything we calculate. So that's why we need to do checks to make sure we are getting close to enough. So what we're going to do, we already seen percent difference as a way to check our experimental values. This is another one you can use as well, is percent yield. So this right here is an easier calculation, I like to think, because it doesn't have as much in it. Just percent yield, we have our actual yield over our predicted yield times 100%, or our actual over our theoretical. So it's what we collect in our experiment and what we have for stoichiometry. So based on that equation, when we look at questions, we'll notice that these here are going to be very similar to some of the questions that we had for our percent difference. The only difference is now it's going to be asking for, well, what is the percent yield? So you're going to see those words. So of course, to calculate percent yield, we need to get our predicted values, so we do need to do stoichiometry. So this is the example that we're going to go through. And then of course I'm going to ask you to just go through your workbooks and try some of these that are in your workbook as well. So we have part A and part B. So for the following reaction, so we have a single replacement reaction between iron and copper 2 chloride to produce iron 2 chloride and copper solid. So for part A, it says, what is the predicted yield if 10 grams of iron reacts with excess copper 2 chloride? So because we're looking at our products here, we see this is aqueous. We can't really collect aqueous. Our copper, in this case right here, because if we're looking at something that we can collect at the end of the day, it has to be something we can weigh, which is going to be the copper solid. So this must be our wanted, and our iron solid is our given. So step 1 is our balanced chemical equation. Now it is given to us, but I just like to rewrite it just so I have everything here, just kind of following the steps that we normally do. And same thing, I'm just going to highlight my wanted and my given just so I have all that there. So when I do the mole ratio, I'm not going to be confused or anything like that. And wanted. Alright, so step 1 is done. Step 2. So this is all for part A. So step 2, find a number of moles are given is equal to mass divided by molar mass. In this case right here, we get our 10.0 grams of iron divided by the molar mass of iron, which is 55.85 grams per mole. And when we solve this, we get 0.17905 moles. Step 3, number of moles of our wanted is equal to number of moles ever given times our mole ratio. So that is our 0.17905 moles times our mole ratio is the coefficient of our wanted, which is 1 over the coefficient of our given, also 1. And of course, step 4, solve the question. Our predicted yield, of course, what mass are we expected to collect? At the end of the day, mass is equal to number of moles times our molar mass. So this is all gravimetric stoichiometry. Of course, our number of moles, we just calculated the molar mass for copper. Just look at your periodic table and you'll find it's 63.55 grams per mole, and we are left with 11.4 grams. Now, of course, this one here, 3 significant digits because the question started with 3 significant digits, and I am keeping 3 significant digits for this one right here just because this is asking what is the predicted yield. So I am saying that the predicted yield is 11.4 grams. Now for part B, this is the new part. This is what would be the percent yield if 9 grams of copper is actually obtained. So of course, what this actually obtained is that someone done this reaction. They produced the copper solid, they filtered it, they dried it out, they weighed it, and they figured out, okay, we only collected 9 grams. So what is the percent yield? So our formula for percent yield is equal to our actual over our predicted times 100%. So our actual is said in part B, we actually collected 9.00 grams. Our predicted from part A, we should have collected 11.4 grams. So our percent yield when we solve this is we get 78.9%. So what this number says is that we actually collected 78.9% of what we should collect. So you'll notice inside the notes, this is the only example that is there, but your workbooks, if you look at your CYU book, after solution stoichiometry, you have percent yield. There's a bunch of questions here. So we got 1, 2, 3, 4, 5, 6, and then of course I know it says quiz 2 review. This is more or less kind of a assignment review because that's all we're doing for our online stuff. So definitely you should want to work through some of these here and try them out. Like I said, we're not going to do a bunch of different examples just because part A, or the stoichiometry portion, is stuff that we've done before. You're doing either gravimetric, gas stoichiometry, or solution stoichiometry, or a combination of them. The only difference is going to be our part B, and that is looking at the percent yield. But if you kept up on your workbook and you've done the percent difference, you will notice that this is very similar, where you're looking at your experimental and your actual yields and stuff like that. So you're looking for keywords when you're reading some of the questions. So make sure to go through your workbook. If you have any questions, please make sure to email me, but this is it for this week. So next week, we're going to be looking at limiting excess reagents. We're going to be looking at titrations. And then the last lesson is on pH curves. It's only going to be a short little lesson. The big ones are going to be the limiting excess reagents and, of course, our titrations. And that will be it for the lessons in Chem 20. So next week, we're going to finish off our entire unit and finish off Chem 20. So exciting. See you guys for next week.